All right, and we're back.
Hey.
So our next speaker today leads a small software engineering team at an HR company. Throughout a career spanning more than 20 years, he's held software engineering and leadership roles for small and successful publicly traded companies such as Hearthlink and Internet Brands, serving business models across content, commerce, travel, and finance on a wide variety of technology stacks, including PHP, Java, and C Sharp, catering to audiences of over 100 million monthly visitors. Chris Holland is also a contributor to Nomad PHP and the PHP Architect magazine, and he has been publishing in CIO Review. This is leveraging typed exception for cleaner error handling. Chris, welcome and take the stage.
Okay. Can you hear me okay?
Yep,
All right. Sounds good. All right. And then can you see my first slide?
yep, all fine.
All right. Okay. All right. So welcome to a talk about exceptions. So if you've been doing PHP for a while, you've been doing software for a while in other languages, you may be already familiar with exceptions. So you might not see too many things that are new in this talk. However, I found it helpful when working with engineers of different levels of experience to try to have something put together to really explain kind of the why exceptions would be beneficial. Using exceptions would be beneficial to improve error handling and end up with more elegant code. So it's kind of helped me communicate better with my teams. I have used this presentation as support to communicate better with my teams, and I'm hoping that it will also help you. So the link at the top, you can download the slides. It's a PDF. So if you click on the link, it will download a PDF, and you'll have all the slides with all the URLs in there as well. Okay. So hello from Austin, Texas, in the United States. So here's me on the left, and here's where I would be if I had flown all the way. So here's also me on Twitter, so feel free to say hi. My direct messages are open, so if you have a question, feel free to hit me up. It's fine. Again, the slides are here. Okay, so let's jump right into it. Let's look at validations in code. And we're going to look at a pretty typical way of doing validations, which in my experience feels a little bit painful. It works. So here's a simple code, right? You may have an if block where you validate a first thing and then you say and validate thing 2 and then and validate thing 3, right? So if all 3 methods return true, then you will get to what's inside the if block where you might do some transaction. And then you want to signal upstream of this code that this was successful. So you might return true, right? Like this code may be inside of a method that returns true. And then if some kind of failure happened, then it might return false. So already this kind of tells you that the code, whichever code is upstream of what's on your screen, is already going to have to handle that true or false signal, right? So now we're going to look at every single one of those validation methods. Each method might look like this, right? If some error condition happens, return false, otherwise return true. Or if you want to just make it one line, you could just say return not some error condition. But sometimes it's less code, but it might be confusing. If you do kind of more explicitly like this, it's kind of more obvious. But that's kind of what the code would look like, right? You would have to have some kind of a validation and then return. So same thing for validate thing 3, return false, return true. So it works, right? But the validation methods, each one of those methods must return true or false to signal the success or failure to upstream, and then upstream methods must adapt their behavior based on this true or false signal. So now your code has more nesting. And when I think of nesting, I like to think of this really funny meme, but I feel this meme to the core, which is kind of this Hadoken pattern, right? This is a code sample which checks a registration method, which checks that the username, the password new, and the repeat matches, right? It checks all of these things in deeply nested if conditions. So Hadoken. So now, if we were to kind of switch this model and kind of embrace exceptions, then the code would start looking a little bit simpler. And this is what the code could look like. So right away, you can see that there is no if else around this code. You can see that my code that used to have one layer of nesting now has no layers of nesting, right? And now what's happening is my validation methods, they're kind of gating methods. Each one of those methods can throw an exception, and if any of those methods throws an exception, then do some transaction will not run, right? So we will never get to this method called do some transaction if any of those methods throws an exception. So now the code for each one of those validation methods, instead of returning true or false, now the code reads sort of more like English. If some error condition happens, then throw a new invalid thing1 exception. For example, I could say throw new user was not found, right? That's a valid exception. So here's validate thing2, same thing. It could throw an invalid thing2 exception, same thing for thing3. So yeah, that's the nice thing is those validation methods don't need to return anything, and they only need to throw an exception on failure. So upstream methods don't have to care, and the code has far less nesting. So we're about to see this at play kind of in a more complex use case. And before we look at this complex use case, I just kind of want to look at layered architectures, because in my experience, working effectively with exceptions has allowed me to make working in layered architectures a much friendlier process. So you may be familiar with the onion architecture, right? That's one variation of kind of clean architecture principles, where you have your domain at the core, you may have repository layers around it, you may have like service layers around it, and then you can have like your infrastructure, your UI, unit test, your presentation layer, which interact with these. That's taken from like a C# article, but I've worked with architectures like this in PHP. It's obviously really easy to do, including in Symfony for sure. So that's kind of a simple architecture. And I kind of want to look at working in a layered architecture without exceptions. Because without exceptions, you could have your runtime. It could be like your framework, right? It could be Symfony. This is kind of the thing that is the closest to your end user, right? That's your framework. That's where all your requests are going to come. And so, below it, you have your application code. And your application code could be made of any number of components. Imagine your components are kind of being a stack, right? And the upper layers call the lower layers, which call the lower layers, which call the lower layers, right? So this is kind of what it looks like, where these three top components all call these two lower components, and these two lower components, call some more components, some of which are shared, and these three components could call some more components, right? This is kind of a pretty extreme example, but it kind of happens. So now that we've got this layered component call stack, let's look at error signaling. That's going to be a big red star. And then let's look at a small red star, which is going to be the error handling. Okay. And the pink arrow shows the execution sequence, right? Things start at the top from the framework, which calls your application code, which calls the outer component, which calls a component, calls a component, right? That's kind of the layer that we just showed. So let's say that one of the lower components, without exceptions. So we're going to look at what happens without exceptions, right? So let's say that a lower component signals an error, right? Like an error happens in the lower component. Without exception, it means that the two components which use this one are going to need to adapt their behavior to handle the error. And because their behavior changed based on that error, it means that the components above them, which use these two components, are also going to change their behavior. And because the behavior of these components change, it means that the components above them are also going to have to change their behavior. Pretty quickly, you can see that without exceptions, kind of an error happening at the bottom of the stack kind of must be handled at every layer above it. And so it kind of has cascading ramifications. And so in this model, you can see that error handling is coupled to error signaling. So now let's look at kind of a layered architecture with exceptions. So same diagram, right? The same stack, but now what we can do is with exceptions, by leveraging exceptions, when an error happens at the bottom of the stack, we're going to throw an exception, and inside of that exception, we're going to encapsulate helpful messaging. So this exception, if nothing catches it, is going to bubble all the way up to the framework, all the way up to the runtime. But now you have the option to catch the exception, to handle the exception at any layer across this yellow, vertical yellow line. So you could catch it here at the bottom, or you could catch it at one of the higher components. Or instead of catching it at the higher component, you might not even catch it at all. And you might configure your framework to actually handle all exceptions to render any helpful error messaging that we may have encapsulated into the message. So what's really cool about this is that now your error handling is no longer coupled to your error signaling. So I'd like you to kind of keep this concept in mind as we look at another more concrete use case example. Let's say you are building an API, like a RESTful API, with an endpoint that says get products for user, right? So it could be, API v1, /product /user 1, right? And when you say get products for user, right away we can think of a couple of failure modes, right? One failure mode would be the user has no products. That's okay. The next failure mode would be the user could not be found. Now that's not normal, right? That means that somebody is calling your API endpoint that says, give me products for this user, and they passed a user ID, but that user ID actually does not exist anywhere in our database, right? So the user could not be found. The user does not exist. So I'd like you to keep these two error conditions in mind for now. And let's look at a possible architectural stack to deliver this feature. You could have your products controller with a get products method to which you pass an integer user ID. Below the controller, you could have a product service with a method that says get products for user to which you pass a user ID. So the first thing that this service is going to try to do is to call a user repository to get a user by ID based on the user ID that was passed. And that's going to return a user object. So then the next thing that the service is going to do is going to feed this user object to another repository, which would be the product repository that says get products to which you pass the user object, right? So the user object that was returned is passed here. Okay. So let's look at this method. get user by ID in the user repository, which returns a user. So this is, some sample code. This is, what some doctrine code could look like using DQL. Instead of using the query builder or one of the find by methods, I just, put some straight up DQL, a DQL string, and I'm calling the get single result method. So I'm passing an int user ID and I'm calling get single result, which means I must get one result back, not two results or not no results, but I must get exactly one result. Okay, so now the question is, what if I'm passing a bogus user ID? What happens when the user is not found? Like Tom Hanks on that island, which he wasn't found. So what do we do when the user is not found in that method? Do we return null? Let's say we're not using exceptions, obviously, right? I'm playing devil's advocate here. So when no user is found, do I return null? Do I return false? Do I return -1? This is what the code could look like. I could be inside of my user repository, and I could, because doctrine is actually going to do the right thing. Okay, so instead of embracing doctrine's usage of exceptions, I'm going to catch the no result exception, and I'm going to perpetrate evil, and I'm going to just return null. So I would like you to suspend this belief. This is not something you would typically do, but this is something I have seen in different code bases where folks are not comfortable working with exceptions, and that's fair. So, if I try to get a user from my database and I did not get any result user, it would make sense to return null. So no result was found, returning null. So now we're at the user repository. So we're going to go one layer up and we're going to look at what the product service does, right? Because now that my repository can return null, my service above it has to handle it somehow, right? So that's what the code could look like, right? In red here in the middle, I'm testing that the user that I got back from my repository is null. So if it is null, I'm not going to go into the code that's below it. I'm just going to, right here, I'm going to return an empty array, right? Because that's kind of what's the most straightforward or convenient to do, right? This get products for user is expecting an array of products back. So since I could not find a user, I'm going to return an empty array. I'm going to say I didn't find any products. So we don't want to send, because obviously we don't want to send a null user to get products here, right? So that's kind of why we're handling it. So yeah, it starts feeling uncomfortable, right? Because right away you can see that if no user is found, I'm returning an empty array of products. That's convenient for sure, but is it elegant, right? Try to think of somebody using your API. So now you get an empty array of the product service is going to return an empty array of products in two cases. One, the correct user was sent, but that user had no products, and no user was found, right? In both cases, I'm going to return an empty array of products. The first case, that makes sense, right? If the user has no products, that's okay to return an empty array. But obviously, if no user was found, that's kind of strange behavior, right? So now if I wanted to address this strange behavior, right? If I want the service to kind of handle this special case, here's a possible alternative. Instead of returning an empty array, now I'm going to return, I could return -1. I could just say, I'm going to say that -1 is a special integer to signal the fact that no user was found. right? Because returning an empty array, that's confusing. Returning null, that could be also misinterpreted, right? So maybe -1 might be better interpreted, right? At least you use some kind of convention. But so now things get interesting because my method can now return either -1 or return an array of products. That's already really weird, right? I have inconsistent return types. That's a pretty big code smell already, right? So in this case, I'm returning -1 to signal that no user could be found. So now my service can either return an array of products or -1. So that's not great, right? Because now you can imagine, we looked at the repository that returns null, and now we have the service that can return an array of products or -1. So above the service, you have the products controller. Okay, so that's interesting. What's the products controller going to do? All right, so now, because the service can either always return an array or return an array or -1, it has two options, right? So we're going to look at what the code for the controller looks like in the two options, right? The first case scenario, option 1, that's when the service always returns an array. So the controller is always going to return an array as well, right? And then we're going to look at option 2, when the controller, when the service below the controller can either return -1 or an array, right? So right now, let's look at option 1, which is kind of the most straightforward with the least amount of code. Because our product service is always returning an array in this first option, the products controller has no way to detect that no user was found. So the products controller is going to send out an empty array in all cases. It really does not have a choice. So now the consumer of products controller has no way to know that they gave us a wrong user ID, right? We're just going to give them an empty array of products, and we're not going to tell them that the ID that they gave us was wrong. So yeah, and now they're going to go on thinking that the user has no products. Okay, so now let's look at option 2. Now I want to try to be more helpful to people using my API, right? So I'm going to leverage the fact that my product service can return -1 when no user was found. And so now the products controller must handle that special case and send a custom error message that says user does not exist. Yes. So in the case of option 1, this is what the products controller would look like, right? It's pretty straightforward. But again, if a non-existent user ID was passed, an empty array is still returned, right? So that was kind of the lazy way to handle things, right? It's basically not handling my error condition. So the API consumer is confused. So now with option 2, when we want to try to handle this exception, and we want to handle the fact that the service returned -1, we're going to have to add some code, right? We're going to add first, we're going to call, we're going to try to retrieve an array of products by calling this product service get products for user. But then we're going to say, whoa, hold on here. My products array could actually be the -1 integer. And so I'm literally handling this right here, and so that I can send an error to my end user that says, you gave me a bad user ID. Otherwise, then okay, I can return my JSON array of products, for example, right? So right away you can see this code smells, right? Like I'm testing for this integer -1 and I'm sending an error. It's just really weird. So the pros of option 2 is, yeah, okay, we don't confuse the API consumer when they send a bad user ID because we tell them. But obviously the cons, is that it's more code, and now we're mixing user-related code with products-related code, and the controller has to know what -1 means. So when you start putting this all together, you start seeing some real impacts throughout your code base, because your user repository could be used by dozens of services, right? So all these services each service is going to have to check for null when no user was found. And then in turn, each service is going to have to find a way to signal upstream of them that the user was not found, and to the controllers upstream of them with an integer -1. And then those controllers are going to have to handle -1 every time. Okay, so now multiply this challenge with dozens of repositories with hundreds of services and hundreds of controllers in your code base. It gets really painful. And what happens is proper error handling becomes painful. And now you end up with like rampant status codes in your code base, -1, -2, 3, 4, to signal all these error conditions. And then you're going to want to bind these status codes to status messages, and you're probably going to try to maintain them in global lookup arrays. It's going to be so much code, and when that happens, things become painful. It means that when error handling becomes painful, it becomes not done. Things that are painful to do just do not get done. So corners are going to get cut, and strange behavior will creep throughout the system. So this is where exceptions can help us. As DJ Khaled famously said, the key is that exceptions are king. So let's look at our user repository. Instead of returning null here, we're going to do ourselves a big favor, and we're going to throw a new exception. We're going to create a new exception of our own, which is user not found exception. And this is what it could look like. It has to extend exception or throwable, and then you can bake inside of the exception, you can bake a helpful user message. You'll notice the end val here. If I know that it needs to be a integer value, then I like to cast it at int val in case somebody tries to do some weird injection hack. So anyway, so as I showed you earlier, the exception flow is pretty simple, right? You have your controller at the top, and then you have your service below the controller, and then you have your repository below the service, and your repository throws a user not found exception. So that user not found exception is going to bubble up all the way up to the framework if nothing catches it, right? And no code has to catch it. If you properly configure your framework to properly display helpful messages that are baked in exceptions to end users, then you don't necessarily have to catch it. So now we can simplify code. Now that I'm throwing an exception at the bottom and assuming that my exception has helpful messaging encapsulated in it, technically I don't have to catch it anywhere. Assuming that my framework is properly configured to render exception messages. So now I can simplify my product service, right? This null handling that I had in there, I can just make it go away, boom, go away. And now my code looks a whole lot simpler. I can just get my user and then pass my user to my products repo and return it. Boom, done. Now that I'm simplified the product service, I can also simplify my products controller, because I no longer have to handle this silly -1 value here. I can just get rid of it, and I can just return whatever the service is returning. Done. Yes, less code. Woo. Okay, so Obviously, some benefits emerge, right? It's less code to handle error cases. You can localize your signaling at the component level. You can encapsulate more information inside of the exception. And as we showed earlier, you can promote decoupling. The upstream components don't have to know about the downstream error cases. You might choose to make them know about it, but they don't have to. So, here's some better practices for exceptions. I like to catch ORM exceptions. If an ORM exception is thrown, it's not going to be helpful to your end user. So you should almost always catch it, and based on whatever it is, try to show something that is helpful to the user. Was it a connection exception, right? Is your database having connectivity issues? Then you might get a lower level ORM exception, catch it, handle it, and then throw your own exception with a helpful message that says, our application is victim of its popularity right now. Please come, try again in 30 seconds, something like that, right? Like a helpful message for the end user. I like to make lots of custom exception classes. Gives me, well, okay. Because it gives me more options when there's an exception hierarchy and a taxonomy to catch them. I'm going to show you a little bit later what that looks like. And also it avoids reusing the same exception with different error messaging, right? So the class itself, the name of your exception class is actually useful to you. And so you should try to leverage that. And the nice thing is now you can embed, instead of using the same exception class and passing to it a different error message, you can just make multiple exception classes, and each exception class has its own message embedded in it. So yeah, I like to give them very specific names and include helpful messaging as to what happened. I like to try to, if I'm echoing, if I'm saying, if I'm trying to echo parts of the input that came into my application, I like to kind of escape that input in some fashion, or try to cast it to some kind of number, right? Just to be mindful of cross-site scripting hacks. So that's why you saw me using inval on the user ID earlier. Okay, so now we're going to look at catching polymorphic exceptions. That's kind of like catching exceptions in different layers. So let me show you an example. We're going to look at the doctrine ORM. We're going to look at some of its code. So before diving into the doctrine ORM code, we're going to look back at our code. So I showed you this earlier, and in this code example, I'm calling a method here called getSingleResult. So getSingleResult is a method that is part of the doctrine ORM. And here it is. So it has two possible failure modes. One failure mode is no result was found. The other failure mode is more than one result was found. Right? GetSingleResult must always return exactly one result. So if no result was found, that's going to throw an exception. If more than one result was found, that's going to throw an exception. So I went to look at the source code for getSingleResult, and here it is. So you can see here where no result exception gets thrown and where non-unique result exception gets thrown. So that's part of the doctrine source code. So getSingleResult can throw either a no result exception or a non-unique result exception. So if I look at kind of the class hierarchy, you have PHP's core, the core exception class for PHP. And so the doctrine extends the PHP exception with its own exception class called ORM exception. ORM exception itself can have several subclasses, one of which is unexpected result exception. And unexpected result exception can have exactly two subclasses. which can be either non-unique result exception or no result exception, right? So if you look, this is kind of the class hierarchy, if you will, right? So no result exception extends unexpected result exception, which extends ORM exception, which extends exception. So this gives you the ability to catch an exception at any one of those types. So I'm going to show you an example, right? You could catch a no result exception very specifically. And so now you're going to put some code in here that is specific handling of what happens when no result was found. Now, below this catch block, you can stack another catch block where you're going to catch an unexpected result exception. So that means this catch block is going to act as a fallback to any unexpected result exception other than no result exception, which is up here, which includes non-unique result exception, right? So if you wanted to catch a non-unique result exception, you could say catch unexpected result exception below no result exception. You know, that's one way to do it, right? It's not super straightforward, but it's just to kind of illustrate the example. So below unexpected result exception, you know, there could be any number of other exceptions that happen, you know, beyond unexpected result, right? There, you could have socket connectivity issues to your database. You could have wrong username and password to your database. You could have authentication issues. You could have table locking issues. You know, there could be any number of things that could happen, and that's kind of when an ORM exception is going to happen. And it's really, you know, this is where you can put code that is even more generic, right? You could throw some kind of you could throw some kind of a exception that says application exception, please try again later, right? It could be something like that. You could log it and then throw some generic exception, which would indicate to the user that they should try to come back later. So that's kind of how you can leverage kind of polymorphism to catch exceptions based on the different types. So here I'm just kind of showing you what some simple code could do. When you catch a no result exception, you could throw a new user not found exception. Then you can try to log an unexpected result if another unexpected result exception happened. Then you can log an ORM exception, right? That's one way to do it. So in the code that we had earlier, just to pursue this example, I could just add another catch block to catch an unexpected result exception, which means that for a given user ID, I had a non-unique result exception, because a non-unique result exception is basically what an unexpected result exception could be, except beyond no result, right? So that would be kind of weird. If for a given user ID you have 2 users in your database, you kind of have big problems, right? So another way to catch exceptions is with pipes. So pipes means or. So they're definitely helpful when you're trying to catch multiple exceptions in the same catch block, but these exceptions don't have a common ancestor, right? They don't extend the same class, for example. So this is what it could look like. I could catch no result exception or non-unique result exception, and then throw a new user not found exception. So if you work with PHP unit, it's very pleasant and elegant to work with exceptions in PHP unit. I like to test drive my code, so it's pretty simple to use exceptions in PHP unit. The first thing that you need to do is you need to declare that what comes next is going to trigger an exception. Then you trigger the exception throwing behavior, and that's it. And so this is what the code looks like. I could have a bogus user ID, and then I'm going to say expect exception, that a user not found exceptions. Now I'm saying, okay, what comes next is going to throw an exception. So I am signaling that an exception is about to be thrown, and then I am triggering the exception throwing behavior with the bogus user ID. And that's it. So if I do all these things, and I actually do throw this exception in my get user by ID code when a bogus user ID is passed to it, if I do all these things, then my test is going to pass. So just to give you a better feel for what the flow could look like, I'm going to switch to my IDE and I'm going to do some live coding. What could possibly go wrong? Am I right? All right, so here's my IDE in a sample project. So I have some tests here that says test get user by ID, where I add user into my data store, and then I retrieve a user by my saved user's ID, and I make sure that the user is the retrieve user. So that's kind of the positive case, right? So I'm just going to run all my tests right now to make sure that all my tests pass. Right, just making sure that nothing's wrong with my test suite. Okay, all right, so this is my positive test case. But now I want to see what is my code going to do if I am passing a wrong, like a bogus user ID to my get repo user by ID, right? So I'm going to uncomment this test. So here I'm just creating a non-existent ID, right? I'm just creating a new UUID by, using Ben Ramsey's UUID library. I'm just going to say, create a new UUID, which I'm going to save into this variable, and I'm going to pass this non-existent user ID to my get repo user by ID. I literally don't have any user in my data store. By the time this test run, there will be no user in my data store which has this UUID. Right? So if I run my test right now, my test is going to fail because an exception is going to be thrown. And it's going to be thrown because my ORM is throwing that exception. You can see here in the error messaging, you can see that Doctrine actually threw a no result exception. No result was found for query, although at least one row was expected. Right? Can you imagine kind of showing that to your end user? That's really not helpful, right? But this is because of my code on the right, right? You can see that my code on the right, get user by ID, just calls get single result, and it's not handling that exception at all, right? So now I'm going to augment my test, and I'm going to say this expect exception. We're going to put it in the app bundle exception folder, and we're going to call it user was not found. Lately, I like naming my exception classes as sentences. User was not found, and I don't add the word exception at the end because this reads more like human language. I like that. Okay, so if I run this test right now, if I run my test, it's going to complain because my code basically does not compile, right? User was not found. My class literally does not exist. So I'm going to make it exist. I'm going to option return, create class. Yeah, it's going to put it in there. Okay, add it. And I'm going to move this to the right. Okay. So now at least my code compiles, right? So I'm going to run my test again, and it's still going to fail because I am expecting a user was not found here. But what I'm getting is the ORM's no result exception, right? So literally, my test is telling me that I got a no result exception, but I was expecting a user was not found. Okay, well, that's cool. Now I just need to make my test pass. So I can go here in my code. I can option return here and say, okay, surround with try catch. And I'm going to handle no result exception. And I'm going to say throw new user was, oh yeah. So it's not letting me throw it right now because it's not extending exception. Okay, all right. So now I can throw it. Throw new user was not found. Okay, gotta love IDs. Okay, cool. All right. So now I am throwing my exception. So is my test going to pass? Yeah, all right, I'm done. Okay, I'm just gonna option return here to replace my qualifier with an import, and pretty much my code works. Okay, there are many other things I could be doing right now, but I don't have time for that. It's not part of the plan. So I'm going to switch back to my presentation and wrap this up. Here we go. So if you're interested in test-driven development, and if you want to put yourself to sleep, or if you want to put your children to sleep, I have almost 10 hours of videos on my YouTube channel of me test driving code, including exceptions, so you can see it there. All right, so to wrap it up, some takeaways here. The nice thing about exceptions is you can fail with poise, you can signal failures with less code, you can handle failures with less code, you can reduce technical debt such that you can build more robust systems. And so exceptions are your friend. Thank you so much for your time. Again, here is me on Twitter. Here are my slides as a PDF. And that's all I had. Thank you.
All right, thank you, Chris. So we don't have any questions so far down the pipeline for the QA, and we're also running a little bit out of time. That said, we are going to go into a lunch break. So I do have one particular question for you. So one of the downsides of using exceptions, especially for newcomers, is when to distinguish when one is doing exceptions wrong, i.e., when one is using exceptions to actually control the flow of the application rather than actually handling exceptional cases. So what would be your advice to guard from this easy mistake to make?
So in some instances, it actually does make sense to control aspects of the flow of the application using exceptions, right? So, if your user was not found, maybe you need to alter the behavior of your service, right? And in some cases, you do need to alter the behavior of some other components kind of, upstream of your exception happening. So to me, it's like anytime you find yourself wanting to return null or return -1 or return something other than what your method is supposed to return, right? Anytime you're thinking of returning something that is not what your method signature's official return type is, in my opinion, that's kind of where you should throw an exception. That's kind of where I would do it. So to your point, it could be that sometimes you just kind of go overkill and you're literally throwing exceptions when it's not really an exception case, but it's kind of a a happy path. I think it matters to look at what lives above your code, right? So how much of the behavior of what's above your code needs to change based on what's below it, and does this behavior needs to change for reasons that have very little to do with your use case? In that case, I would say that's when it makes sense to throw an exception. But if what's above it, you're trying to change your behavior that's basically that conforms to valid use cases, then yeah, in those cases, it probably doesn't make sense to throw exceptions. That's kind of, it's, I should try to find examples of that and try to cover that in my next iteration of this, because I think that's a really good question. So.
Perfect, but yeah, your rationale makes total sense. Think about the problem domain, I guess, and see what are the actual exceptional cases and what are the cases that you actually have to just take into account. So yeah, perfect. Thank you, Chris. It has been a delightful talk, very interesting. We've had very nice feedback from the chat.